In this video, we will look at an example which uses a quadratic application, and we'll use the context of the problem to find the function's domain and range. So Bob plans to build a fenced garden where one side of the pen will be the side of his house. For the other three sides, he has 60 feet of fence to use. Okay, so the first task says find a function to model the area of the rectangular pen with respect to the width, which is the two perpendicular sides to the house. Okay, so often with these problems, I really encourage you to draw a picture of what we're looking at here. So this is the house over on this side, and we're going to fence in a garden, and we've got 60 feet of fence to use, and we want a function with respect to the width. Okay, we could call it W if we wanted to. We could call it X. You can call it anything you like. I'll use X here. Okay, so I know that those two sides that are perpendicular to the house are the same, right? So the problem gave us a nice little hint, right? It says find a function to model the area of the rectangular pen with respect to the width. And the width is the two sides perpendicular to the house. Okay, so if we have that length be equivalent to X, right, then this third side has to be the total amount of fence that we have minus the other two sides, right? And we've got two of the X's, right? So if we add up all of those, 60 minus 2x, and then we add x, this one length and the other x here, we should get 60, right? Because we've got 60 feet of fence to use. Okay, and how do you find area? Do you remember how you find area of a rectangle? Length times width, right? Now, in our case, our width is x, right? So I'm really going to find a of x, is what I'll call it. And I am going to, the width is x and the length is 60 minus 2x. Okay, right? So instead of having length times width, I've got width times length, but it's the same thing there, okay? And so let's distribute that x through. So we have 60x minus 2x squared, okay? So we end up having a quadratic function that models the area. So our final function then would be a of x equal to 60x minus 2x squared. If you prefer to have the highest power of x come first and put these in descending order, that's fine, but it really doesn't matter one way or another. Okay, so then it says find the dimensions of the pen such that you can enclose the maximum area. Okay, so we've got this function that we just found, and we notice that the leading coefficient is negative, right? So that means that the parabola opens down. Okay. And we've got a vertex here that's a maximum. So when it says find the dimensions of the pen that you find the dimensions of the pen such that you can enclose the maximum area, we're really looking for the vertex of the parabola. Right? And in particular the x value, because that'll give us one of the dimensions, and then of course we can find the other one because it's 60 minus 2x. So what is the x coordinate of the vertex? So you may remember a little formula to do that. Negative b over 2a will find the vertex, right? And the y coordinate is f of negative b over 2a. So the x coordinate will give you the width that will maximize the area, and then the y-coordinate will give you the maximum area itself. Okay, and remember when we're talking about b and a and all of this, we're looking at ax squared plus bx plus c, right? And that's kind of that standard form. Okay, so in our case, what's the b value? 60, right? Negative 60 over... So it's negative b over 2a, right? And our a value is negative 2. Okay, so that would give us negative 60 over negative 4, which is 15. Okay, so if we're looking for the dimensions that will yield the maximum area, if the x value is 15, then that's the width, and then the length would be 60 minus 2 times 15, right? $30. Okay, so the dimensions that maximize the area of the pen are 15 feet by 30 feet. Okay. All right, so then it asks us, what's the function's domain? Let's think about this. The function's domain is the set of all possible values of x, right? And x is the width, and we've got 60 total feet of fence. So in order for this to be a rectangle, we've got to have 3 sides. So if both of the sides, and we've only got 60 feet of fence, so if both of the sides were 30 feet, we'd be in trouble because there wouldn't be enough fence for a third side, right? But even if they were slightly less, then there would be. So I would say that the function's domain is 0 to 30, and I'm not going to include either endpoint, right? It has to be more than 0 or there's no pen. And if the width is more than 30, then we also don't have a pen, right? There's not enough for a third side, and it can't be 30 either because then there's also not a room for a third side. So between 0 and 30, but not including 0 and 30, is a good domain for this function. All right, to find the function's range, we have a slightly larger amount of work to do. We found the x-coordinate right here, yeah, of the vertex, but we never found the y-coordinate because the question that they asked in part B didn't involve that, right? It just said find the dimensions of the pen that would enclose the maximum area. So let's go back and find that value. So we found the x value to be 15. So the y value when x is 15, that means we've got to find a of 15, right? So we got negative 2 times 15 squared plus 60 times 15. Feel free to stick that into a calculator, right? 450 is what I'm getting. Okay, so the maximum value, right? The area, obviously, if there's a pen at all, it has to be at least 0, yes. And it really has to be more than 0 if there's a pen. And it can be at most 450 square feet. Okay, so just a word about the units here, and I guess I didn't add them up above. Bad me. So, right, so the width that we got as the x-coordinate was in feet, but the area, the output of the function is in feet squared, right? Because it's a unit of area. Hopefully this is making sense. Again, when we have a quadratic, what we initially found in part A, that function, you would look at it without any context. You would say, oh, the domain and range is all real numbers. But when we look a little bit more closely in this example where we actually have a number of feet of fence that's available to us and some specifications on how this pen is to look, then that makes a big difference in our domain and range. Okay.